Okay, so the question is, how many of these molecules are polar? To figure this out, we're first going to draw the Lewis structure and then identify the bond dipoles using different electronegativities, and then we're going to identify the net molecular dipoles based on the molecular geometry. So first we have SO3, and in SO3 there are 24 electrons. So we're going to first fill up the oxygen octets that are on the outside. So now that all the oxygen octets are full, there are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And we're going to subtract that from the total electrons, and that gives us 0. But the S octet is not completely full, so we're going to have to take one of the 2 of the electrons from one of the oxygens and bring it into a double bond, and to make it everybody have a full octet. So to count again, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so that works. And then what we're going to do, now that we have a Lewis structure, we know that the atom with the lowest electronegativity is going to be in the middle. So the S is going to have a partial positive charge, and then the oxygens are going to have a partial negative. Okay, so now that we know the charges on each of the molecules, we are going to figure out the bond dipoles, which shows the direction of change of the charge separation. So this is going to show how the electronegativity is going towards the O, because this is more electronegative, and so the arrows are going to go this way, away from the S, for all 3 of them. Now that we have the bond dipoles, we are going to move to the molecular geometry, and we know that there are 1, 2, 3 bonds, so there are 3 domains, and this means that it's going to be a trigonal planar, and it's going to look like this. And because there is a double bond on the O, it could be on any of the O's. There's going to be a partial bond on all of these, which is going to make it 1 1/3 bond on each of them. So with that, the bond dipoles for the molecular geometry are going to go towards the O, because it is more electronegative. And now, because we don't have any non-bonding electrons over here on the central atom, this makes all 3 of the oxygens the same, so it's going to be nonpolar. And all of the dipoles will cancel. Okay, moving on to OF2. There are 20 electrons, and we're going to have O in the middle, and then we're going to go out to fluorine because it is more electronegative, and we're going to fill out the outside octet. So with that, there's 2, 4, 6, 8, 10, 12, 14, 16. So we're going to subtract 16, and then we're going to have 4 left. So we can move those onto the oxygen atom. And then 1, 2, 3, 4. Then we're going to count that again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that fits all the electrons with all of them having a full octet. Now we will know that because the more electronegative atoms are on the outside, the dipole is going to pull this way, and the center atom is going to have a partial positive charge, and the two fluorines are going to be partially negative. And the arrows are going to go towards the fluorine. Now that we have the Lewis structure, we are going to figure out the molecular geometry, and there are 4 domains, the 2 bonding pairs and then the 2 non-bonding pairs. So that is going to bring us over here to a bent molecular geometry because of the 2 non-bonding pairs. And the bond dipoles are going to go towards the fluorine. And because these are not all equal and the same to where they can't cancel out, we're going to have a net dipole, which is going to go down because both of these go down. So with these not all being the same, this molecule is going to be polar. Now with BeCl2, we know that there are 16 electrons, and we're going to fill the outside octet first. And we're going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 14, 16. Okay, so there's 16, which leaves 0 more electrons, but we still have not filled in the BE octet, but because this will violate the octet rule, but this one is allowed with BE, so we are going to leave it as is. And Cl is more electronegative, so they're going to have a partial negative charge, and Be is going to have a partial positive charge, which is going to make the dipole go towards the Cl, like that. With now moving on to the molecular geometry, there is 2 domains. So this is going to be linear because we don't have any non-bonding pairs, and our arrows are going to go out to Cl again because it's more electronegative, and because they're the exact same, they're going to cancel, and this molecule is going to be nonpolar. Okay, moving on to CCl4. There are 32 electrons in this molecule, so we're going to fill the octet. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So this one uses all the electrons, and the central atom has a full octet, so we don't have to worry about adding any double bonds. And the central atom, C, has the lowest electronegativity, so it's going to be a partial positive charge, and all the Cl's are going to be negative. All right, now with our bond dipoles, our arrows are going to go towards the Cl. And now that we know this, we can move on to the molecular geometry, which will have 4 domains. and it's going to be a tetrahedral. So this is what that will look like. And our dipoles are going to go up. Oh, go. Our dipoles are going to go up and towards the CL. I'm sorry, my camera froze. Towards the more electronegative atom. And because all of these are identical, they are all going to cancel, and this molecule is going to become nonpolar. Okay. Lastly, we have O3, and with O3 there is 18 electrons. So we're going to fill the octet of the electrons. 2, 4, 6, 8, 10, 12, 14, 16, and we have 2 more. So we know if we put that there, it doesn't fill the middle. So we're going to have to bring electrons from one of the outside oxygens and bring it into a double bond. And this will cancel. And now we're going to move to the molecular geometry, and we are going to figure that out by us knowing that there are 3 domains, and there are 2 bonding and 1 non-bonding. So that's going to give us a bent molecular geometry. And because there's a double bond and it can go on either side, we're going to put a partial charge here, a partial sharing, and that's going to be 1.5. And the arrows, the dipoles are going to move towards the oxygen, and it's going to create a net dipole because all 3 cannot cancel because of this non-bonding, and the net dipole is going to go down. And because the bond dipoles cannot cancel, this is going to be a polar molecule. Now, with that being said, going back to this question for our polar molecules, it's going to be O3 and OF2. Now, some common mistakes students can make are forgetting that the outside octets need to be full before going into the inside to fill the octets and creating those double bonds. And another common mistake is to be sure you know what elements can break the octet rule, like BE in this situation. Also, make sure to remember that whenever you have a polar molecule, that a nonpolar molecule, everything connected to the central atom has to be the same for it to be nonpolar. So whenever it's polar, there's going to be something different, like the non-bonding and the bonding electrons.